Hey guys, we're going to review for our end of the unit on irrational numbers. So what I did is I put together a bunch of questions on the different topics that we've covered. So the last one you guys were working on were rationalizing the denominators. As I go through these questions, if you are still confused, you can always check out the videos from the other assignments that I posted, or get a hold of me so we can meet over Google Meets and we can go through these questions before you take the quizzes test. But you got to reach out to me or find me during those office hours, because I most certainly will be available to help you through video conference. So either try to print this paper out so you have it, run through the questions with me, or just do these questions on a separate sheet of paper, but definitely do this before you take your test. Okay? All right, so let's go through and simplify these. So since we're not asked to add, subtract, multiply, or divide, looks like we're just simplifying. So you gotta see, what we're gonna do is you're gonna end up splitting this radical up, because 27 isn't perfect. So I know I can split that up into 9 and 3. 9 being the perfect square. Now, when you work with variables, you always have to ask yourself, what are you dividing by? So because this is just a regular radical, you're dividing by 2. So can you divide 2 by 2? Yes, so I'm gonna bring that one here. So b to the third, that's going to be the weird one. I cannot divide 3 by 2. However, I can split my b's up so that I can divide by 2 with one of them. So when I go to actually take the square root of this, square root of 9 is 3. A squared is really just dividing by 2. So 2 divided by 2 is 1. So I'm just going to say a to the 1. Same thing with b squared divided by 2. Well, that's just b to the 1. And you just leave that one at the end. So that's your final answer. So if I take a look at this one, I have a -5 in the front. Now square root is 60. I know I'm going to have to split up because it's not perfect. So I know, you can say, okay, what is the largest perfect square? I know I can split this up into 4 and 15. Now the next part is you look at your letter, your variable, and say, okay, 7. Can I divide that by 2? No, but I can divide 6 of them by 2, which leaves me with 1 extra one over there. So I'm left with -5 times the square root of 4 is 2, times m to the 6 divided by 2 would be m to the third. And you just leave this one as is. That's your irrational piece to it. So this part is where you're going to have to simplify. So my final answer will be -10 m to the third times radical 15m. All right, if we move on to the next one, same thing. Looks like I got to split this up. Okay, so 63, I know I can split up into 9 and 7. Now look at your exponents. Again, we're dividing by 2. So x squared I can divide by 2. Same thing with y to the 10th. I can divide that one by 2. So really, just left with radical 7 over there. So go through and take the square root of these now. Square root of 9 is 3. X to the second divided by 2 is x to the 1. Y to the 5th, because 10 divided by 2 is 5, times radical 7. All right, now to adding and subtracting. Now remember, you can only add or subtract like radicals, just as a reminder. So 4 times radical 7, I can't do anything with that, so I'm just going to leave it. However, I know I can split this one up into 9 and 7. So really, I'm left with 4 radical 7 minus 3 radical 7. These are your like terms. Just treat these as x's. So what is 4 minus 3? Well, that's really 1, and you carry over your like term. So radical 7. All right, so with this one, so it looks like I'm going to have to split up radical 125. So I can split that up into 25 and 5 minus 3 times, I'm going to split up radical 20 into 4 times radical 5 plus 2, and I can split 45 up into radical 9 and radical 5. So I had to split these up. And if you notice, there's some like radicals in here. So let's go through and simplify. So I get 5 times radical 5 minus, I know this square root of 4 is really 2. So negative 3 times 2 is really a negative 6 radical 5 plus square root of 9 is really 3. So 2 times 3, again, is 6 radical 5. Remember, only like radicals. So with this one, I actually have 3 like radicals. So you go right in row. So what's 5 minus 6, which give me a negative 1, plus 5 is really, sorry, plus 6 is really 5 radical 5. So again, if you need to, just do that in your calculator. 5 minus 6 plus 6. Multiplying. All right, so multiplying, you do not have to be like radicals. So what I'm going to do is I'm going to combine and say what is 4 times 12. So that gets me 48. A times a to the 5th is a to the 6th. Now if you notice, this looks very similar to a question that we did up here. So now I'm going to say okay. So 48, what is going to be the largest perfect square that I can divide into that? So I'm going to split up my radicals. So I know I can split that up into 16 and 3. And then say, okay, a to the 6. I'm dividing that by 2. So I'm going to put all of them here. So when I go to take it, this becomes 4 a to the 3rd radical 3. All right, this one kind of looks like something that looks like this. So you guys know you would have distributed. So same thing here. I'm going to distribute, but you're just multiplying those radicals. So this becomes a negative radical 50, so 5 times 10, plus, actually, sorry, minus, because a negative times a positive is negative, minus 3 radical 5 times radical 5 is radical 25. Say okay, so I can split this up into negative 25 and 2. So I just split that one up, minus 3 times 5. So I get negative 5 radical 2 minus 15. Now that's my final answer because, again, you can't add or subtract. These are unlike radicals. So that's why this is your final answer. Okay. All right, almost there, guys. So this one looks just like I'm going to do my double distributive. So this gets me 20. Let's zoom in a little bit. 20. Now 4 times radical 2 is 4 radical 2 minus 5 radical 2. That's that. Then I have minus radical 2 times radical 2. Well, that's just radical 4. So if I go through and simplify, here are my like terms. Again, because they have the same radical. So I have 20. So 4 minus 5 is really going to be a negative 1 radical 2 minus, I know that I can simplify that to 2. So my like terms are going to be 20 minus 2. So this gets me 18 minus radical 2. Okay. All right, anytime you see a squared, just think of it as radical 3 plus 8 times itself. So if I go through and multiply, so radical 3 times radical 3 is just radical 9 plus 8 radical 3 plus 8 radical 3 plus 64. Combine your like terms here. Easier to see. Square root of 9 I know is 3. 8 plus 8 is 16, radical 3, plus 64. My like terms are 3 and 64. My final answer is going to be 67 plus 16 radical 3. So there's your multiplying piece. All right, rationalizing your denominator. So this is just where you cannot have a square root at the bottom. So all you're going to do is you're going to multiply the top and the bottom by whatever the radical is. So since I have a radical 2 down here, I'm going to multiply the top and bottom by a radical 2. So this leaves me with the square root of 48 over the square root of 4, which at this point we should be able to skip that step and just put it over 2. Now you can actually simplify this down a little bit more. So for 48, what is the largest? So I can split this up into 16 and 3 over 2. So which is 4 radical 3 over 2. So if I look at this, I can cancel that out. 4 divided by 2 is 2 radical 3. So that's simplified. So that's just going from here to here. All right, so rationalizing the denominator with conjugates. This was the very last thing that we did. So all you're going to do is you're going to multiply the top and the bottom by the conjugate. Now that just means conjugate means the opposite. So I'm going to multiply this by 5 plus radical 7. So what happens is I just multiply this out. So on my top I get 20 plus 4 radical 7 over. Now if you need to, you can multiply this out. Here's a trick. Just multiply the first two numbers. That gets me 25. And just multiply the last two numbers, which is really square root of 49, which is really 7. You'll always have a subtraction in between. So you get 20 plus 4 radical 7 all over 18. Now, in order to simplify, honestly, I'm just going to have you leave it like this. You could simplify these fractions, but don't worry about it. Just leave it like that for now. Okay? We'll do one more example of conjugates. All right, so I need to multiply by the conjugate, which in this case is going to be minus. Multiply this by square root of 8 minus 1. All right, so now I got to go through and multiply these out. So this gets me 14 radical 8 minus 14 over, so 8 times 8. So again, here's the trick. 8 radical 8 times radical 8 is just 8. You're always going to have a subtraction. And then 1 times 1 is just 1. So you are left with 14 radical 8 minus 14 all over 7. Now again, you could leave it like that. What I'm talking about is you could actually simplify, and again, it has to work for both when you do this, but it only works for both. So this is really 2 radical 8 minus 2, because 14 divided by 7 is 2. You can actually take it a step further and simplify your radical. So this is really 4, because this is 2. Radical 2 minus 2. On a test, I will be completely okay with that answer. Okay, but if you take it this step further, even better. All right, guys, there's your review. If you are stuck, please get a hold of me before you take the test so we can go over these questions. What I'll probably end up doing is just pulling up this review sheet and we can walk right through. through this. So let me know if you have any questions. Get a hold of me during office hours. Shoot me an email and say, hey, I'm available Thursday at 2 o'clock. I can look at my schedule and hopefully I should be free then.